Hello again. Are you there? So I'm back and we can continue. Hi.
Hello.
Hello. Okay, I see. I thought maybe the students went out for coffee as well. No, I needed a coffee. And now fresh again, energized. Second part. I will share my screen again. In the second part, compared to the first part, so that was more general introduction concerning risk and water-related risk, and a couple of things you already knew, but maybe with a different perspective. And the second part is now about risk and vulnerability concepts and definitions, which is very important if you do your research to understand the conceptual approaches of risk and their relevance, because it matters what concept, what perspectives you are using when you study a problem like water-related risks, for instance, droughts or floods, for instance. And I will show you this with a couple of examples. And the second, aspect I want to present to you and share with you some insights about participatory approaches concerning vulnerability assessment, which we are doing in a couple of projects. And then I will not talk about so much on vulnerability indicators, but more on how to do it in generally. And then Dr. Pamukçu Albers, she will then introduce you more on different indicators, indices, because that matters, of course, how you study the vulnerability, which is then influencing the risk, the results, or the evaluation of risk, and also depend on data availability and so on. However, okay. Then conceptual approaches of risk and their relevance.
Professor Ivers, just for your information, we can see also your notes. So maybe you should just change your screen again. Ja, duplizieren, genau.
Like that?
No, it didn't work.
I think maybe you exit the presenter view mode.
Oh.
And now?
Still, we can see your notes.
And now?
We cannot see your presentation anymore.
Aha. That's fun. I did it the same way as for the first part. Okay.
I would suggest maybe you open the PowerPoint and then before you share it on the Teams, make sure you deselect the presenter view mode, and then you can later on share on the Teams.
Mm-hmm.
Not sure if you follow it.
I don't know how to do that.
Okay, before you share it, just open your PowerPoint.
Yeah.
And then go on to presenter or PowerPoint view. Full screen view. Did you open your PowerPoint?
Yeah.
Okay, let me just make sure I just direct you. Then once your PowerPoint is open, they just go on slideshow. Then right click.
That should be work now. I think I found it.
Oh, okay.
Like that?
Yeah, no, that's fine now.
Yeah, it's fine.
Okay. Thank you. I learned something today. In PowerPoint. Okay, so that was my introduction already. Okay. Concerning vulnerability, which is part and part of risk. There are different definitions. One is from UNISDR. Vulnerability refers to the physical, social, economic, and environmental conditions which increase the susceptibility of the exposed elements to the impact of hazard. And what we have to consider is that vulnerability is not directly measurable. You need indicators for that, and you will learn about a lot of indicators and indices. And the factors have different meanings and influence. For instance, I already mentioned the example, the amount or the share of agricultural use in a region or country is influencing, of course, the risk. And the aspect is has a different severity, so to say. So that some indicators are more relevant than others, and the kind of weighing is necessary if you look at these the different vulnerability aspects or indicators. So the risk and the vulnerability is context specific, and the importance of the indicators are varying. So weighing should be necessary. So far, no stakeholder participation, vulnerability assessment, and modeling processes is, at least in generally, is implemented or only seldom implemented. So what I'm now presenting is this participatory way of vulnerability assessment. This is a case study in Brazil. And the PhD student of mine, Mariele Madruga de Berito, she worked on this case study in Brazil, in Tacares Antas, and there was this participatory vulnerability assessment, and also she used the multi-criteria approach to assess the risk. You will see in a minute how that worked. And there was a constant stakeholder engagement in the index development process. I don't mention now the methods specifically, but I will show you the approach, general methodology of the approach. So this is the basin, and this region is very much prone to floods. GDP is quite low, and 20% of the households are below poverty line. I will not explain all the case study. It's now more about the vulnerability assessment in this participatory way. But it's important to know a little bit about the structure. So lots of areas are prone to floods, regular flooding. There were 32 to 33 flood events in 30 or 40 years, and 8,000 persons living in flood-prone areas, of which is flooded every second year. So highly flood-prone. So what she did is identification of the stakeholders who should be involved in this participatory assessment. And then she did with snowball sampling, and then a selection of vulnerability criteria using a Delphi survey. Pınar will explain it to you how it is done. But selection vulnerability criteria for this region and for this topic is important. So there is a range of literature about vulnerability criteria, but not every criteria you find in literature is relevant for your case study. Then the criteria were structured into sub-indices. Then the standardization in GIS was done, and then the weighing criteria were identified together with the stakeholders, with decision makers, science, regional experts, and so on. Then again, criteria aggregation and visualization was done. And then, of course, it was important to get a feedback and validation of the results. So this is one result or one way of collecting these indicators based on the literature research. And then Marianne asked the stakeholders, so which is most important or very important, important, moderately important, slightly important, or not important, you know, or which indicator is not yet in the list. For instance, we added then escape routes and disaster simulation and training, because this indicator was not mentioned in the literature. This is very important, and the stakeholders said, yes, this is a very important indicator, as you can see from the long red, dark red bars. And this is then the basis for the weighing as well. Then it was structured, the vulnerability criteria in coping capacity, structural vulnerability, and social vulnerability. And then what is here mostly interesting, I think, Pınar, you will go to this aspect as well. So there are ways of weighing it, of course, and also, let's say, statistics to do that. But the interesting aspect I want to show you here is that you then in the end are producing different maps. So spatial information on vulnerability for this region, this case study area, differentiating low and high vulnerability. And what you can see, so this is a joint vulnerability map. But if you have a look at the different criteria types, like structural and physical vulnerability or social vulnerability or coping capacity, it looks different. They're quite high, differentiated, because at these, let's say, cells in these regions, the vulnerability is really different. You have this spatial variability or spatial differences, which is shown here very nicely, concerning also different types of vulnerability. Why is that important? This is very important when it comes then to the assessment, of course, first of all, and as well then for identifying intervention measures. What you also did is to have a look at the different criteria. So you saw in the previous slide the group criteria, but if you have a look only at the distinct criteria, this is also quite an interesting information. But what is especially also interesting is when you differentiate the vulnerability maps by person or expert group. And you can see that the different experts consider or evaluate the vulnerability in that region in a different way. And this is quite important and interesting aspect when it comes to planning of measures, integrated risk management. When you know, okay, this person thinks that this vulnerability aspect is very, very important, then you can consider, you learn from each other. That is one thing. Social learning, you learn from each other during this process. This is one thing. And the other thing is that you can negotiate better. You know what is relevant for the others, or what we should consider or we should not, because we don't think it's really important to consider. And in the end, this is a quite differentiated picture of the vulnerability in terms of different types, different criteria, but also concerning the persons who are managing risk, and that is quite an important aspect when it comes to integration your study results in practice. Okay, this is one example I want to share with you, and as I said, Pina will talk about more concerning indicators and the methods behind. And another example I want to share with you is the Paradis project in Ghana concerning participatory assessment of flood-related disaster prevention and development of an adapting coping system in Ghana. Ghana is one of the countries most prone to floods in Western Africa, with devastating effects. We're working here since 4 years now. There are heavy floods every year, pluvial and fluvial floods. And in 2017, country experienced extreme floods that affected about 1 million people. I know Mozambique, Angola, Southern Africa also face these very, very, very heavy floods. Just as an example, Ghana is also in that group, which is facing many, many floods. So, and this is one thing, and I already mentioned that a flood is not only disastrous event because there is this inundation. However, you have to consider cascading aspects. Floods are triggering, for instance, disruption of critical infrastructure, electricity, power plant, cooling, affecting sanitation plants or hospitals and so on. So there are these cascading aspects, and that we are investigating as well in this project. Yeah, this is structure. As I told you, we are working with quantitative, with hydrological models, hydrodynamic models, but as well with these participatory approaches. And this is one example in this project. We call it a socio-technical approach. And if we want to not only analyze a problem, but also would like to provide information and results for implementation into practice, we need also to have a look at the governance structure. Governance means so the structure of decision making, who is information change, and who is making decisions in which context, and who is responsible for what implementation, for instance, of flood risk management plans. So this is also the project objectives are identifying flood hazards, risk and cascading risk on critical infrastructure, and climate and land use changes. Then identify flood risk management key mechanisms and understand the human flood dynamics. How is that related? And what we're also doing is developing an innovative web-based mobile decision support system and a flood label. Flood label is an assessment for yourself, for private households, if your house is potentially affected and how it is affected by a flood. And how can I change, I don't know, with a couple of measures, the level of risk. So this is a flood label, flood assessment on the for private persons, for households. We are developing scenarios, sustainable action plans, and feasible measures, and to enhance coping capacities of the communities. And we are doing a training specialists and decision makers and policies. And what I'm going to show you here is what kind of methodologies or method which are related to each other are used in this transdisciplinary project in a participatory way. We have a continuous exchange with partners, of course, literature research, survey, and so on, which is normal. Workshops, we started during Corona. We had a lot of online workshops and also hybrid and in person. And what we did together is to identify jointly the case study areas together with our partners, and also joint formulation of research questions and the design of the project. And in the end, we formulated relevant research questions. You can see some illustration, what we how we worked together, and on the left side the map, how we identified our case study areas, which is in Accra, in Kumasi, and the Volta region. For validation and ground truthing, you know, world is uncertain, and with climate change, it's even more uncertain and complex. And we can run models, we can set up models, but data availability is always a problem, and so on. So validation and ground truthing is a very important aspect. What we do together with stakeholders for validation, ground truthing of data is, for instance, beside data collection, surveys, community, so citizen science, examples of citizen science, that's one thing, but also participatory mapping on web-based participatory mapping. Regional experts can integrate information on maps, where are hotspots of floods, where are very vulnerable people, and so on. So this is integrated in our model. Focus group discussion, of course, in the field work and mapping. So this is our way in this project to improve the database and validate and ground truth the data, and also the models, hydrologic and hydrodynamic models, and also the damage model for the critical infrastructure, the risk cascades. A couple of illustration, of course, focus group, field trips, and so on. And we also identify the interrelation on the left upper side part of the slide. You can see again this system dynamics approach to identify interlinked system elements. And this is participatory mapping. What we can see is that we match the model results together to match the model results with the input feedback from the stakeholders. Yeah, and you know, creating knowledge is not always then generates action. How do we maybe not assure, but try to improve the chance of implementation of our research results? Of course, we elicited the needs and wishes for the information system and decision support system, where all this information are included and displayed and web-based provided. We developed this and including as much as possible the needs and wishes from the stakeholders. We know the interaction of human and floods using the scenario Of course, actor network analysis is very important. And yeah, PhD, we run a PhD together with one institution who is involved. So one partner is extend, so to say, the group with a scholarship, and it's, which helps then, because this person is employed at one institution which is a partner of us, and then this is most probable that this knowledge is then also implemented in this institution. By doing this, we try to reduce the mismatch between knowledge and action, and because there's a need for sustainable implementation of research results. This is one aspect, and so this is just some illustration of this, what we are doing, and some joint knowledge production and mutual learning is also an aspect. What we want to and how we want to increase the knowledge and in the jointly knowledge processes, mutual learning, again with groups and workshops, continuous exchange, participatory scenario development, but a lot we are doing with training of specialists and decision makers, policy makers, and so on, and online courses, and this training is very much closely developed together with our institutions, with our practice partners, to meet the needs also the partners, so how the training should be tailored. Yes. And just some illustration how we jointly develop scenarios, which includes then aspects or ideas of the stakeholders, what should be studied, or what we have what we should have a look at, and not only climate change scenarios but other scenarios, how the problem at flood risk can be reduced. Yes, and then ownership and sustainable implementation. Yes, of course, again, interaction, but also this decision support system will be in use. Then we will develop a flood risk management plan, but also not only our scientific papers, but also policy briefs and a handbook, and you need an enabling environment. And this we cannot guarantee or we can organize, but this is kind of boundary conditions, of course, when it comes to budget, personnel, and so on. But then the chance is much higher than to generate ownership and the increase of the chance of sustainable implementation. Yeah. And my conclusion for MCDA and also participatory approaches. By doing this vulnerability assessment, these different, maybe I could show you in the first example with these different vulnerability maps. They are different views on vulnerability, and a multifaceted perspective is possible, and this validity of this information is increased by this participatory approach. We are using Delphi, MCDA, and these participatory approaches for have a high transparency, reproducibility, and this weighing, multi-criteria decision analysis, this weighing of criteria is not a solution, of course, but it's showing possible alternatives, how to assess something and how to identify then priorities for interventions, for measures which should be implemented. Inclusion of expert, increased integration of knowledge, and also the social learning and acceptance and the chance of implementation. And vulnerability analysis enables focus and questions about the process and understanding, especially when you are doing the process together with the decision makers. Okay, and with this, I would like to thank you for listening and again give time for questions. Okay, please. I think that were a couple of new things to you. I try to illustrate it. Do you have questions?
There are no questions from the room.
Okay. We provided you the list of literature, and there are a couple of papers which explain the methodology, which illustrate these approaches. Then, Pina, what do you think? Do you want to continue?
We can continue with the exercise
Mm-hmm.
and then have 5-10 minutes break. I mean, depends on time.
Mm-hmm.
And then we can continue. I mean, I can continue to teach.
Okay.
Is it okay?
Okay.
Yeah.
Yes. Then I'm handing over to Pina.
Okay. Yeah. Thank you. So I can share my screen. Just a moment. I think right now you can see my presentation, right?
Yes.
Yes.
Okay.
But in the not in the presentation mode, in the presenter mode.
Okay. Yeah. So like this.
Yes.
Okay.
Perfect.
Super. So we prepared an exercise for you just to, I mean, to get an idea and whatever you have learned so far, just to wrap up basically. So we can, we can talk about a little bit about flood life cycle. So as this research defined, so we have 3 phases for the floods. And first one is pre-flood. Second one is during flood, so when the flood is happening, basically. And the third phase is post-flood. So, and we are taking some measures and we are applying some, we are applying some management strategies and so on during pre-flood to mitigate or to reduce floods or flood risk and to be more prepared for the flood, right? So this is the pre-flood phase. And during floods, actually we can talk about responses, because during floods also we have to react immediately while we are having this disaster basically, or this hazard basically. So this is the response phase, or during flood phase we can say. And for the third phase, I mean after flood or post flood we can call, we are trying to recover and trying to find out which kind of damage we have because of flood. So, and all these 3 steps, of course, I mean, we can talk about different stakeholders involved. We can also say different aspects, different sectors are affected by flood in different phases, basically. So different management strategies we need, applications we need, and different adaptations measures, different mitigation sections we need to we need to have basically. So in this case, my question is, which intervention or interventions or strategies can we apply concerning these three flood phases in order to reduce vulnerability and increase resilience? So you can maybe spend just 5-6 minutes to put bullet points, which kind of interventions or strategies we can do, for example, for pre-flood and also during flood and post-flood. Is it clear?
Yes.
Okay, that's great. Then just I will start right now. Yeah, more or less 5 minutes, and you can just maybe you can just talk also to each other, and then I will basically try to write here whatever you said, and I will compare what I wrote also. Okay. If it is also okay for you, we can just discuss. It's already a little bit later than 6 minutes.
Okay.
I'm very curious to hear whatever you talk. Yeah, so we can start to discuss a little bit about pre-flood. So what did you talk about? Which kind of measures or interventions we are taking?
Okay, maybe let me present what we have just brainstormed
Okay.
across all the phases of flood events there. So looking at mitigation, we have brainstormed a few points here to say there need to be infrastructure developments which are kind of flood-proof or dams to, store excess runoff. Still under infrastructure development, proper drainage facilities. But then, of course, proper is subjective depending on the magnitude of the floods, but it has to be sufficient. Maybe looking at historical events of flooding, because a proper drainage facility today might not suffice in the future. So this one is subjective. And then moving on to the preparedness, we need to do research. But then that research needs to be communicated and also involving stakeholders so that we can have improved early flood warning systems.
Okay.
And then also moving on to response and recovery, there's an overlap of adaptation. As a way of responding, we also need to adapt. We are adapting because some things we really do not have control over them. So then we might have to live with those. In case maybe the mitigation measures are failing or are overwhelmed. So also as means of recovery again, we still need to adapt and be used to such events, whilst we are going back into the loop of how can we mitigate such challenges in the future.
So just a moment, adaptation and mitigation in this case are during flood phase, you said, right? Or I misunderstand? So adaptation, I wrote here, and also mitigation measures.
No, I was saying adaptation would overlap.
Okay, yeah, overlap. Yeah, okay.
It's a way of responding during flooding. Sometimes it's also good to be resilient. So one way of those is through adaptation, because once the flood is already there, the only thing you could do is coexist with it. So this is why we have adaptation and a response. And then also post-flooding events also need to have the same feature of adaptation again, featuring in the recovery phase.
Okay, yeah.
This is why I was saying maybe this point of adaptation will be an overlap for both during and post.
Yeah, so like this maybe, you said. Okay,
Yes.
yeah. Anything else?
Did I leave anything?
Yes, on the recovery, we also talked about stakeholder engagement. On recovery, stakeholder engagement.
Yeah, stakeholder engagements again under recovery. So we don't need to be isolated. Different sectors have to actually come together and map a way forward, because it will not maybe affect only the water sector, even the energy and the food sector.
Yeah, yeah. Yes, we cannot definitely put them separate for any phases, I would say. But I also prepared something, whatever I read, and I just came to my mind basically. So I can show you here. For example,
Sorry,
maybe
can
I
just
of course.
There's a contribution here.
Another contribution, at least for the mitigation and preparedness. Can you hear me?
Yeah, yes, I can hear you.
Yeah, we also, I think, just to complement the physical infrastructure development, looking more into the issue of nature-based solutions. So the role of ecological infrastructure and looking at how that could actually be used under like catchments or to try and alleviate the floods.
Yeah, definitely. And do you think we should use this nature-based solutions approach during pre-flood phase or post-flood phase? What do you think?
I think ideally it would actually link into what we've said earlier on, where it could come post-floods, but then use that as a forward planning for resilience, building resilience in case such similar events occur in future. So
Yeah.
I think it would post and then building resilience, more of a forward response strategy.
Yeah, but I would say also it's related to pre-flood at some point, because you need to be prepared for the flood. And if your city or your region is prepared for the floods based on regarding ecologically or economically or social, so it would be better. I mean, they can be resilient for the flood. So in this case, we can just use nature-based solution approach and apply basically for the places that where we need, basically, I would say. So, but also, I mean, if you know already we are prone, I mean, the area is prone for the flood and already have floods, and we have some, I don't know, I mean, damages at some point. Also, we can approach with this nature-based solution. So it depends. We cannot put them separately, as I said before. So these are all what I prepared, and we can also see the research what they wrote. So maybe I can just read very briefly. So they said that for mitigating the floods and flood risk, let's say, we need to do risk analysis, we need to do hazard and vulnerability analysis. So this is the pre-flood phase. And for the preparedness, we need sometimes warning protocols and good planning and good training. So training also includes education and awareness. So, and this in the yellow box, what I prepared basically for you. So we can talk about during this pre-flood, we can talk about measures, we can talk about preparation. So that means evacuation simulations, who will go where, for example, or how we will leave the place that affected by floods, for example. So, and we need to improve plans and systems as well. Awareness we need, and vulnerability also we need to reduce, and coping capacity we need to increase, and education, sharing knowledge results, and of course maybe we need to do prioritization, because we cannot be really prepared for the flood for every aspect of topics. Then we need to prioritize. So, and during floods, we can talk about real-time monitoring, as the researchers wrote, and safety assessment and contingency planning. So, and what I wrote also, for example, emergency and escape routes. So it immediately we have to act, we have to react, let's say, during the flood. And if we know already where we will just run run away from the area, then it would be very nice. But we need to have certain routes in this case. So, and sometimes we need some meeting points, hotspots in the prone areas and so on. And in this case, a little bit early warning system can be useful to get real-time information. And for the post-flood, they said that assessment, planning, and requirements, but also we can add assessing damage, for example, how much damage we had because of floods, or management, which kind of management we need to take care, or lessons learned, what we have learned already, and how we can recover, how we can take measures in this case. We can use, as you said, nature-based solutions to respond all these things. And again, we can do prioritization, because we need to do. We cannot immediately recover everything. So we have to put them together and prioritize. And I'm not talking only about infrastructure. I'm talking also about vulnerable groups, or in general people, right? So these are the three phases of floods, and we can take different measures, we can do different applications, and as I said before, many stakeholders are playing a role, and we need them to be involved for each process, basically. Before I start my presentation, we can have a break, but maybe we can have a break. So maybe in 5 minutes we can meet again, and I can use 5 minutes more. Is it okay for you?
Yes,
Yeah?
that's fine.
Yeah,
Yeah.
5 minutes. So 11 we can meet. Okay?
Okay, thank you.
Thank you. Okay, I think we can start. Hi, super. Yeah. So I think you will you are seeing right now my slide. Oops, like this. Is it working?
It's not on slideshow.
Not yet.
Oh, okay. So I will just stop sharing because it was shared. Just a moment. Right now?
Yes, perfect.
Okay, super. So thank you. So yeah, we can start. Just very briefly, first part and second part, what's presented by Professor Evers, we saw that water is really middle of everything what is related to climate change. So we talk about scarcity and water-related hazards, also floods, droughts. Maybe I can add also forest fires and other hazards as well. And we learn about irrigation, little bit food security, fresh water, and also deficit. And I can also add hurricanes, glaciers, dams, dikes. So whatever we are talking actually about water, it is related to climate, but also vice versa. So also climate is really, I mean, playing a crucial role on water. So, what we are doing, I mean, we are trying to find out how we can cope with climate change risk. It can be, of course, I mean, there are in general adverse impacts, so adverse consequences also we are getting because of climate change. But also sometimes we can use some opportunities or beneficial consequences from climate change. Depends. I mean, mostly we are working on adverse impacts and also consequences because they are much more and much more intense than beneficiaries. So, and today this part is vulnerability components. I will present, and it's maybe I can just show the content of my presentation. So I will just very briefly talk about flood-related challenges and impacts of actions. And already Professor Evers mentioned about IPCC risk approach. I will just very briefly talk about that. And then I will talk flood risk factors and basically also indices and indicators. And I will show some methods for vulnerability assessment, also risk assessment. And I will conclude my presentation at the end with all these topics, let's say. So on the left side, you can see flood-related challenges. Maybe I can show with pointers. So, for example, personal or societal vulnerability we can talk about as flood-related challenges or the reason of these challenges because we don't know the future and we can have potential losses, we can unfortunately have fatalities and so on. So this is the social, let's say, aspect of flood-related challenges. And we are also facing some issues on food production, biodiversity, or habitats, or pollution, or freshwater scarcity, what we have saw already. And also we can see on local level, sometimes destroyed riverbank and natural areas. So they are ecological aspect of flood-related challenges. And of course, I mean, it is related to economic aspect, government or privately, people have to recover or have to assess the damage and basically implement restore it again and use some management strategies and so on. And they are all of course about money and they cost a lot mostly. So about the transportation, if you think, or gray infrastructure, again, nature-based solutions or sewage system. So they are all, basically public infrastructure that can be affected by flood and that the government or privately we have to recover, let's say, or rebuild or restore it, let's say. So, and of course, different sectors are affected by floods. So agriculture and freshwater, tourism, and even forestry, that they can be affected by floods. And of course, we can lose or destroy, destroy on cultural heritage as well. So this is the cultural aspect of flood-related challenges. So, and on the right side, you can see how IPCC is approaching all these impacts, let's say. So risk is in the middle. And as we as human society, we are emitting greenhouse gases a lot, and we are contributing to climate change, unfortunately, negative way. And but at the same time, we are trying to adapt, we are trying to mitigate and climate change, and we are doing sometimes wrong, or something is going wrong, let's say, and we have at some point maladaptation or malmitigation. So these are the positive and negative effects from us. And of course, I mean, climate change also is affecting us negatively. So we have like now some limits to adaptation, and we have some losses and damage from the floods or from the forest fires or heat waves, right? I mean, from all these aspects, basically. So we are not only the one who is affecting climate change, ecosystems also are affecting, but in a good way. So they are trying to adapt, they are mitigating, I mean, for example, emissions and so on. So they are positive, they have positive effects, but they are getting, unfortunately, negative effects from the climate change. And of course, they have also some limits to adaptation. Not only climate change, but also human society is affecting ecosystems, because of our demands and our needs, basically. But also, at the same time, we are trying to conserve and restore ecosystems. So, and we are getting some ecosystem services and livelihoods from these ecosystems. And we can put risk is just in the middle of all this circulation, basically. And from now on, if we improve governance, finance, or technologies, or knowledge and capacity, and the perspective of our behaviors and so on, so we can get this impacts little bit improved. So we can adapt more, we can mitigate more, and yeah, as you see here, for example, greenhouse gas emissions are not here because, yeah, I mean, we need to adapt and we need to have resilient development. That's why we need to have no emissions anymore. So this is how they are acting or how they are approaching the risk assessment. So, or risk approach. So we need risk approach in this case. So, and here I just take this risk here basically. So IPCC is defining risk as a function of three factors. So vulnerability, one factor, hazard, second factor, and exposure, third factor. In this case, maybe it is good to mention some terms. For example, what factor means. So it's basically it's a statistical way. I will explain you. So it's a common element with which several other variables are correlated. So we can talk about vulnerability as factor, how IPCC define, and we can understand that vulnerability is a common element. So it's showing something, just one thing to us, but also it has some variables together that which they are yeah, correlated to each other. So this is one thing. And we are talking about variables. If we can let's say measure these variables or try to quantify these variables, then they are becoming indicators. And set of indicators, they are defined as index. So it's a little bit complex, I know, but I can show you here. So vulnerability, for example, is a factor of risk. And we can talk about some indicators. Persons under 12 years can be vulnerable. We can say persons over 60 years, persons with disabilities, and some other. So they are variables basically, but because of quantification, they are becoming indicator. So we are trying to find out how much vulnerable, how much social vulnerable we have in certain area, let's say. So, and we can name as index all these indicators overall, this set social vulnerability. So we are trying to find out social vulnerability index in this case. So, and maybe, yeah, we can just go to the next slide. So yeah, hazard, as you see here, it's a potential occurrence. We are talking about physical trends or physical events for the hazard. So that means physical trends and events, that means meteorological and hydrological. So, and yeah, climatological as well. So meteorological. So normally we as a person, we don't have so much things to do to reduce hazard when they are occurring basically. So just before that, we can take some measures or do some actions maybe, and all the behaviors and infrastructure, whatever we have applied, that they can affect or yeah, reduce the hazard risk, let's say. So for the exposure, it is IPCC also defined as the presence or the existence of infrastructure or people or livelihood or systems. So, and that yeah, could be they could be adversely affected by flood or by drought or other risks. So I will focus on more flood. That's why I'm saying flood risk factors. But of course, this is in general risk risk approach from IPCC. So you can also use for other water-related risk assessment, these three factors. And vulnerability, as you see, it is about, first of all, concepts of sensitivity and also adaptive capacity. Sometimes we are also putting coping capacity. So, and basically it is about like propensity. So it's like tend to be adversely affected. So if you have not good building structure, or if you didn't use really good building materials, then your building can be vulnerable for flood. Or again, for vulnerable groups, if I talk, for example, we will talk more, but for example, elderly people or women, most of the times is vulnerable than men in many cases for the flood. And yeah, we are putting them together and we are having risk in this case. So we are assessing risk. So yeah, I will just skip this one. We already talked about it. And yeah, basically, last year we conducted an assessment, let's say, on flood risk. Yeah, for recent, we checked recent publications from 2017 until 2022, and we searched for which kind of aspects and applications that they used to assess flood risk. So, and we saw that there is no basically single definition, and there is no single aspect, and there is no single application, because as you see here, sometimes they are defining or assessing flood hazards, risk or areas, let's say, to generate flood risk maps. So they are defining only hazards, let's say, as flood risk. Or we can also, we faced also some research which are generating flood hazard and vulnerability. So both of them to generate flood risk, but where is the exposure, for example? So maybe I should also tell her they are all after IPCC changed the definition of risk, or changed the approach of risk-based approach. So at the beginning, there was an approach which is vulnerability based. Right now, we are using vulnerability as a factor of risk. So right now we are using risk-based factor or risk-based approach. Sorry. So yeah, as you say, for example, flood susceptibility assessment. Normally, susceptibility is one of the concept of vulnerability, but they just try to evaluate flood potential. Of course, I'm not saying they are wrong. They used they use wrong, but this is how you are defining the risk, basically. That's why there is no single definition, I would say. Also, it is based on your area, how you get all these feedbacks from infrastructure, from meteorology, from hydrology, all these feedbacks, and also approach. If you think you will find out a risk map or risk distribution, let's say, just based on hazard, then if you don't find any vulnerable thing or potential exposure, then maybe you can approach, or you can use this hazard risk assessment, let's say, to generate flood risk. So yeah, anyway, so I mean, right now we are using this risk factors, let's say exposure, vulnerability, and flood here, basically. So it is multi-index system, one of the research defined. So this is how we should or we can find out our risk, flood risk or drought risk or some related climate related risk. So and for the hazard, we can, I said before, it is physical trends, it is physical events. So that means climatological and or hydrological reasons. So our question should be how many or how much? So how many will answer frequency, and maybe duration, and how much is like intensity and magnitude. So as you see here, return period of storm events or flood depth, flood duration, sea level rise, all these indicators can help to assess hazard factor for the risk assessment, let's say. So and this is from our research, basically, what we have done for the literature review last year that I mentioned already. So we found out which kind of indicators the researchers used for assessing hazard. And we already grouped all these indicators to see which one is which one comes to for the most. For example, for the hazard, if you remember, climatological and hydrological here hydrological reasons we said, and in this case we can also add topographical and as Professor Evers mentioned, also human impacts. So in this case we can also put land use and land cover and many other things, basically, that are related to human impacts. So here, for example, 12, maybe I should also tell, we checked 30 publications we reviewed, and 12 of these publications, 12 out of 30, they used contour and slope to find out hazard. So 8 publications, they used elevation to find out hazard. So this is how we can read the table. So, and as I said before, topographical, hydrological, and meteorological indexes or indices, in this case, come to the fore the most. And for example, here you cannot see, except population density, any other socioeconomic indicator, basically. So it's also interesting, but it's also normal to find out like this. And as you see, so many indicators we have for the hazard. So, and all of them, we are that they are playing role for the hazard. I mean, directly, indirectly, or really too much or really less. So it depends again wherever you are working and whatever you are trying to focus on, let's say. And for example, when I show here this sea level rise, it is not from our findings. It is we couldn't find sea level rise as hazard indicator. So it shows that the indicators are really especially crucial where you are working. So we can say context specific. For Bonn, in Germany, sea level rise is not a problem as a hazard to assess risk, but for Hamburg or and for other cities in coastal area can be a problem, and most probably we would see as indicator for the hazard. But from 2017 until 2022, whatever we reworked, we couldn't find any sea level rise indicator for hazard, let's say. So, but as I said before, I mean, it is really important where you are working and which kind of indicator you can find, and you want to, you can find data and you want them to be involved, let's say, for your assessment. So, and exposure, we exposure of the system affected. So we are asking where and how. So they can, I mean, we can answer about topography, we can answer about infrastructure in this case where they will be affected. And for example, distance from the rivers, drainage density, curvature, and imperviousness. Also, what we also found as indicators for exposure. And I mean, there were not so many research about exposure. Even the exposure was one of the factor of vulnerability assessment before IPCC assessment report 5. So, and mostly they used this distance from two rivers or drainage. So only 3 publications. And as you see, there is no geological, there is no meteorological or vegetation index here. So really less indicators and indices we found. And for the vulnerability, the question is how vulnerable or how much able. So it is depending on design and maintenance of infrastructure and also existence of early warning systems. But I would, we should also say it is not only about infrastructure, but also about people, so vulnerable groups and so on. So, here, for example, again, the same, we didn't find disaster prevention institutions or, evacuation drills and so on. Many other things also, distance to shelters and so on. When we checked, when we reviewed, let's say, but also, I mean, it shows again, where that the indicators are especially important where you are working and which time slot that you are working also to focus on. So for the vulnerable group, maybe just one two sentence about that. Women, for example, elderly people, smallholder farmers, indigenous people, rural coastal populations, children, migrants, and persons or people with disabilities that are, we can define them vulnerable. And you can add some more others, for example, foreign people. If they cannot understand the language, maybe they cannot find a way how to run away or how to behave during the hazard, let's say. So, for example, for smallholder farmers, they are vulnerable because they are depending on rainfall patterns. So less rainfall or more rainfall can also affect them. Or children, for example, I mean, yes, they don't know what to do during this flood event, let's say, but also they need some psychological and developmental needs. So maybe they need to leave the school at some point, or they are facing all the time the issues what flood caused. So this is all. I mean, this is all why we have some vulnerable groups. I mean, and we should know about them to be aware and to be more prepared for the floods. So for the vulnerability, we found many socioeconomic indicators, of course, because it is related to people. So population density, education level, vulnerable population, this is what I mentioned before, and number of households and income level, etc. And also built environment, because also infrastructure is important. If you have if you have a kindergarten just next to the river, next to the one of the tributaries of very big river, I don't know, just next to it, then this kindergarten can be vulnerable of flood, because flood can cause anything on this kindergarten. So also roads, also land use, building areas, which kind of building you are using, building material you are using, and so on. So everything is related to vulnerability in this case. So, and we found out some indicators for susceptibility. So it was mostly about topographical, hydrological, and also built environment. And basically susceptibility is like it's a potential degree of flood harms, or harm of flood, let's say. So they also used some indicators. So what I wanted to say, I mean, we saw 4 factors, let's say susceptibility also as factor. And as you see, some of the indicators are common for these 4 factors. So, for example, land use, or slope, or drainage density, also I would say elevation. So they are common for 4 factors. But this is of course possible. We cannot say slope is just used for susceptibility or used for hazard and so on. It is related to how you are defining your indicators for certain factors. I just give some information from the research what we have reviewed. For example, for the roads, for example, one of them, they said that humans tend to build settlements near roads for better accessibility. So roads become immersed and led to major issues in communication and accessibility. So that's why they said that roads are vulnerable, or indicator for vulnerability. The other research defined roads can result traffic congestion during floods. So that's why it's vulnerable, or it's an indicator of vulnerability. Or the other research said that we should take care, or we should minor roads are vulnerable because they can just washed away during the flood event, and that's why they are vulnerable. So just imagine, I mean, even vulnerability, you can, for just one indicator, you can define so with so many perspectives, and you can find your indicator in your area, basically. And also roads, I mean, can be an indicator for vulnerability, but also can be an indicator for hazard. For example, one research said that road network, in the city we have so many road network, and they disrupt the natural slope leading, and it is problematic for water logging. Or one of them said that it is because of surface runoff increment, it's harmful and creates favorable conditions for floods, and that's why it's a hazard indicator. So I mean, just we should be, I mean, if we are working on this assessment, this risk assessment, or just one factor assessment, vulnerability assessment, then we need to focus on our area. We need to focus on which kind of indicators we have, and we need to really define the indicators and indices. So, and we need to see distribution of the risk or vulnerability to support policy making, and also to get some to take some measures and to apply some let's say actions, or to act, let's say. So as I said before, for the assessment report 4, vulnerability was the function of exposure, sensitivity, and adaptive capacity. So after assessment report 5, hazard came out, and hazard, exposure, and vulnerability, which includes this adaptive capacity and sensitivity concept together. So they are they become and became as a risk-based approach. So it was vulnerability, right now it's risk. And one more comparison here you can check, just to read maybe a little bit easier from this one. And yeah, basically we are trying to find out risk, so we need to multiply probability and consequences, and we can say consequences equals exposure multiplied by vulnerability, and also we can just open the bracket, exposure multiplied by adaptive capacity plus sensitivity. So this is how we are approaching the risk. In this case, maybe we can also say this adaptive capacity is like a ability of systems or institutions or people, ability. So to respond to consequences, or to take to use the opportunities. So this is adaptive capacity. And sensitivity is like to the degree, or the degree to which system or people that can be affected by flood. So it's a kind of a, yeah, I don't know, degree, less or more, or in between, So yeah, also it can be good to mention here. And we are measuring vulnerability to identify vulnerable areas. So, and we are using, as Professor Evers also mentioned before, indicator-based methods. There are some other methods, of course. I mean, you can also put some more other, based on some more other, research, but mostly we are using indicator-based model. So it is really common to use flood vulnerability, but also flood risk studies. So it's a tool basically for policy making. You are just showing all these indicators, whatever you are whatever you are comparing, and weighting also, and you also are showing the participatory approach, who were involved, who were the stakeholders, and so on. And it is really useful to read the results for the policy decision makers basically. So, and of course it helps for the public awareness. It helps also to support government and so on. So that's why we are using indicator based methods. So in this case, we should ask, okay, we are using indicator based methods, but how can we define context specific indicators? How can I know wherever I'm leaving the indicators about this area, or where can we find them, or how we can use them for modeling or for mapping, how we can distribute all these things? So these questions are pointing out us actually to use participatory assessment, participatory vulnerability assessment, or in this case, participatory risk assessment. So on the left side, left photo or left image is showing articles, basically article analysis over literature review, what we have done last year, also under one of the project that we are engaged with Myanmar universities. So, and they used, I mean, we did again a systematic systematic literature review, and more than 60 research this time we reviewed, and we saw that at the end participatory vulnerability assessment definitely is used one of the common way to assess vulnerability, and the research are related to public perception, public attitudes, or communication gaps, or social resilience. So these are the keywords what we found out during these 5 years, what researchers work on based on or regarding participatory vulnerability assessment. So, and on the right photo, you can see articles, analysis over methods. So here, for example, survey and interview is coming for the most, and participatory mapping as well, and dynamic modeling. So you can also say participatory modeling and so on. So, and you can also find out on the distribution based on the years, which kind of method was the was using more. So for example, for dynamic modeling, it was really it was really too many during 2017, but 2022 we found less paper about dynamic modeling, or the one used dynamic modeling for participatory risk assessment, let's say. So and basically we are using this participatory approach. Basically we need to include as much as possible stakeholders and stakeholder opinions. So because we need some information that we cannot find anywhere else, we need people tell us which kind of conditions they have, or which kind of demand is increasing, or what happened in the past, and so on, and also their experiences. So it is all about participatory approach. That's why we are using participatory approach. And for the indicator-based approach, yes, we are using indicators, but we need to find out indicators first, and also stakeholders people, whoever involved in our research, let's say, they are helping us in this case. So, and how we are doing it, I mean, of course, stakeholders, we can have some focal group discussions, or games we can play, or actions we can do together, just to be aware also for certain for certain variables, let's say, and interview we can say, and some other methods also. We can maybe start with the participatory for example, review frameworks. Maybe I should also say here, for example, dynamic modeling, participatory modeling. In this case, we are using kind of a combination of approaches. So we are checking the frameworks, and also we are trying to put as input as much as possible for local knowledge. Sometimes we are doing some workshops or meetings and trying to model for certain local goals, let's say. And for example, participatory mapping, again, local special knowledge. And yeah, we are trying to prioritize also at some point for the aspect whatever we are working on. I mean, in this case, vulnerability. So we need to find out, for example, critical infrastructure distribution, and we have some data from internet and from the institutions, but also we need to put some input from the local knowledge. So that's why we are doing altogether, let's say, participatory mapping. And maybe it is good to mention here this multi-actor criteria assessment. So one of the tool is AHP, so is analytical hierarchy process. I'm very sure you know. So it is also related to stakeholders directly, and also weighting based on their opinions or their experiences. So that's how we can find out which indicator is more relevant than the others, or which indicator is more important than the others. So this is AHP. And Delphi methodology, again, it's a kind of assessment or methodology that we can use questionnaire for the stakeholders. So you can see, also, I mean, we cannot again put them all separate. We just wanted to group, but also we are using in general mixed methods. So we are working with the stakeholders for mapping, for modeling. We are doing some workshops also, some focal group discussions as well. And yeah, we are trying to find also, let's say, most relevant and important indicators for vulnerability or risk assessment. So yeah, I mean, here, for example, review frameworks. We can review frameworks or strategies or processes and so on. So of course, I mean, we need literature review in this case, and this is one method. And another method, as I said, mixed method. So more than one method we can use for vulnerability assessment, this participatory vulnerability assessment. It is really good to mix, but of course it causes some complexity of conducting research, right? Because you need more resources and additional field trips maybe, or education and so on. So it's a little bit complicated, but in general, we are using this mixed methods as well. So here you can see participatory modeling process. It's one of the participatory vulnerability assessment. So several steps we are starting with the process preparation and again, ranking of alternative and outcomes. So trying to integrate these outcomes to the decisions, plans and agreements. But also it has some limitations as well, because at some point maybe the governance is still lacking on this participatory approach, let's say, all this stakeholder involvement and opinions and so on. So governance can be a problematic in this case. And for the negotiated participatory actions, so for example, during workshops, participatory workshops, we are trying to find a problem and then make a plan and act and reflect and agree. This is the process of this let's say, participatory action. Of course, I mean, we can also face some stakeholder engagement issues in this assessment type, basically, example. So yeah, of course, I mean, some possibilities they have. I mean, every method, every approach has also at the same time some limitations. So, and one thing what we are mostly using, it's mixed, as I said before, and mixed method includes also multi-criteria assessment, which we can use Delphi technique and also analytical hierarchy process. So we are defining the indicators together with the stakeholders, together with the stakeholders, and all the data, whatever we have collected, let's say, and then we are having some questionnaire processes and find out which indicator is most important, which one is less important. And yeah, I mean, basically stakeholders are giving this information you. So especially if you don't know where the area where you are working, if you don't know about that, then it can be problematic, right? I mean, I cannot know, for example, one of the drought indicators in a village in somewhere else in some countries. I cannot know, but stakeholders can be involved in this case, and they can wait. How much important is this? So that's why it's important. So, for example, here, the index. In this case, in my regarding my term, I would say factor, vulnerability, and exposure. So index like social vulnerability, physical vulnerability, and copy capacity. And they have some indicators, and they have their own certain value, basically. So certain mean value that you need to weight them when you are overlapping together. So, and we need fight flood vulnerability, of course, reduce flood vulnerability. We need to have maps and determine, first of all, what or where or who vulnerable, and we need to have prevention and mitigation strategies. So, and why we are doing this vulnerability assessment, of course, first thing is to reduce damage and help policymakers and to measure vulnerability and identify relevant indicators. This is one thing what we also use. So, and you already saw from the presentation of Professor Albers, just very briefly, for example, one of the examples from this researchers, they used 3 indicators: exposure, sensitivity, and adaptive capacity. It seems is vulnerability assessment approach what IPCC is showing, or IPCC was guiding, let's say, before assessment report 5. So exposure is like frequency, population density in this case, and protected waters and so on, and sensitivity and adaptive. Of course, I mean, again, all these indicators are depending on where you are working. So, and for example, this European Commission JRC, they have 2 type of susceptibility and 2 kind of capacity. So lack of coping capacity and adaptive capacity. Again, I mean, this is also depends. This depends also how you are explaining, how you are defining your indicators. So, and we have some gaps and needs. I will just very quickly, of course, I mean, for the drought, we need interaction, human and environmental interaction. It's a gap. Validation can be a problematic, and future scenarios can be uncertain. Potential solutions also, or potential pathways can be a problematic, and so on. So they are the gaps, and we need conceptual frameworks for adaptation, for adopting, and most of the cases, let's say, and yeah, further research, of course, and yeah, to integrate our research results, as Professor Evers mentioned, and also not only for drought vulnerability, but also in general for the vulnerability and risk assessment. So maybe just one question before I stop, before I finish my presentation. Which institutions and or who can use the results of the flood risk vulnerability assessments? What do you think? You can just tell me. So we are doing this assessments, risk and vulnerability. And what do you think? I mean, who can use these results? Who can use, or which institution can use these results? Any answer?
I think, from my opinion, everyone can use this results. Everyone, in the sense that those who are in the flood-prone environments, primarily they need this information. And those that
Yeah.
those from such sources, they might also need it to be prepared in case there could be flooding in the future. So to speak about institutions, maybe I might just give a blanket approach to say all stakeholders, everyone in the community and society. So that's my opinion on who can use that information. So basically everyone.
Yeah. Also, I would add, for example, municipalities can use to concern planning, critical infrastructure, blue-green infrastructure, and so on. So fire departments can use these results, and rescue groups also, it can be useful to see the flood-prone areas. And what you saw also, the presentation, yeah, by Professor Evers, insurance companies can be related, and also private for the vulnerable groups or critical infrastructure and so on. So they can use this information. Just very briefly, we have also uncertainties, so we can have, of course, I mean, inherent randomness of flood events. We don't know when and how much flood we will have, or which kind of which kind of damage we will have. So this is one of the uncertainty, of course, I mean, for the even for the assessment. And of course, some multiple source we need for the indicators and indices weighting. This is one of the uncertainty reason. And also stakeholders judgments. I mean, it can be related for many other things, and can be also problematic, but also at some point data uncertainty, future climate, we don't know what to do and how we will face, right? Or what we will face, let's say, in the future, or socioeconomic modeling, uncertainty, and yeah, also for the human behavior. I mean, everything is uncertain and unknown, so that's why also they are reflecting in our assessments. So maybe I can just very quickly conclude. So we have, I mean, we need to find out social vulnerabilities. So it is depending on poverty, inequality, and marginalization. And we need to study focusing on more micro scales as well, because many are done at macro scales. So, and we need to develop some solutions for the vulnerability and also, yeah, associated with climate variability. So we need to find out where the risk-prone areas are, past change, what happened, current situation and future expectations, and where are the most vulnerable groups and infrastructure situated. So yeah, we need to have a bottom-up approach and then short and long-term approaches as well for vulnerable groups and vulnerable infrastructures. And yeah, I mean, the damage from flooding could be reduced even if the frequency of flooding increases, if measures are taken that reduce the exposure and vulnerability of affected systems. So it is depending. You can just reduce some factors like exposure and vulnerability, then even hazard is really high, or yeah, frequency of the floods is higher than before, then maybe even you can decrease the damage of floods. So it depends. So yeah, thank you so much. If you have any questions, I would be very happy to answer. Too much information, I guess. If you are talking, I cannot hear you. No?
Okay, we have the question on one of the slides, which shows the formulas for directing it. I cannot take any picture, but we can see it. Yeah, so that slide, it has 3 equations. So
Yes.
Yeah, so I want to find out what are the units for the equations. Are they measured in terms of percentage? Yeah, so I just saw the formula.
Yeah, thank you for the question. And it is very important. I didn't mention, but we need to standardize these indicators. So either we are using, for example, kind of a range like 1 to 5 or 1 to 9. So we have certain, let's say, scale that we can range all these indicators and find out one certain I don't know, I mean, one certain, let's say, average value for the index. So we are standardizing it with the range, with the, yeah, basically score or range. I would say range, definitely. 1 to 5 or 1 to 9. So you need to find out basically with the stakeholders which, I mean, which indicator how much related to the index, let's say.
And they are showing that it's a product, so it's just numbers like 2 being multiplied by maybe 10 by 13. That's all.
Yeah. I mean, you have to do for, I mean, I don't know if I understand true, but you have to do for each indicator this ranging, let's say. So you will create a hazard map and then vulnerability map and then exposure map, and all of them will come together to find out risk distribution of your area.
Okay, maybe my concern is they just mere numbers like 1, 2, 3, 4, or they have to have units like percentage.
Yeah. No. It is not about percentage. I mean, if you are talking about, for example, the distance from the road network or distance from the drainage network, let's say, then it is meter, and the stakeholders should define how much meters away from the roads or from the drainage can cause more flood damage or more affecting people. So I mean, they are having meters, let's say, some scaling, and then they are putting 1, 2, 3, 4, 5. So most affecting one, can have 5, for example, and less affecting indicator can have 1. So this is how we are scaling. I mean, there is no meter or percentage, nothing else. It's just 1 to 9 or 1 to 5 number scaling. Yeah. Yeah, I also provided some further readings, so you can also check which kind of methods and approaches they used, and you will be more familiar after this lecture for all these indicators and the approaches, let's say. But yeah, thank you. So I guess we can finish. So yeah, Professor Albers also had to say goodbye. So I would say also goodbye. Any question, any comment?
I don't see any questions from the room. Let me just take this opportunity to thank you and Prof. Albers for your 2 lectures.
Yeah, okay.
Yeah, we have learned 1 or 2, 3 things.
Yeah, I mean, it was very nice also for us to use this opportunity to meet you. So if you have any further questions or comments or just, I mean, just write to us, contact with us. We're always open to work together. So yeah, see you next time then.
Okay, thank you. Just one last request. If you could maybe forward the presentation material to Ronel.
We can talk about that. Yes. I mean,
and then they'll just redistribute amongst us.
Yeah, okay. Yeah, I'm taking notes right now, so I will talk and try to find out. All right.
Okay, all right. Thank you.
Yeah, thank you so much. See you later. See you next time.
Okay, bye.
Bye.